somewhere, buried beneath centuries of silence, there's a secret that an entire empire took to its grave. Not a myth, not a legend, a real gap in history, one that the most powerful civilization of the ancient world understood perfectly, and that we, with all our modern technology, still cannot explain. This is that story. Every great empire leaves something behind. The Romans left roads, still driven on today. The Egyptians left monuments, still standing after 4,000 years. The Greeks left ideas that still shape how we think, how we govern, how we build. But every empire also takes something with it when it falls. A technique, a formula, a method so closely guarded that when the last person who knew it died, it simply vanished. History is full of these moments. Knowledge that reached extraordinary heights and then disappeared. Tonight, we examine one of the most haunting of them all. A substance so effective, so feared, and so completely lost to time that modern scientists, armed with chemistry, archaeology, and centuries of hindsight, still argue about what it actually was. The Byzantines called it Hygron Pyr. The rest of the world came to know it as Greek fire. To understand why this mystery matters, we need to go back to a world on the edge of collapse. The year is 674 AD. The Byzantine Empire, the eastern continuation of Rome, centered in the magnificent city of Constantinople, is under siege. An Arab naval fleet, massive and highly organized, has arrived at the mouth of the Bosphorus Strait. Their goal is simple and total: capture Constantinople and with it, control the known world's most strategic crossroads. By any military calculation of the time, Byzantium should have lost. The Arab forces were experienced. They were well equipped. They outnumbered the Byzantine defenders, and they had already swept across enormous portions of the known world in just a few decades. One of the most remarkable military expansions in all of human history. But something stopped them, something that no one on those Arab ships had ever seen before. From the Byzantine warships came a substance, deployed through tubes, through siphons, possibly through hand-thrown containers, that caught fire on contact with its targets. And it did not behave like ordinary fire. It burned on water. According to multiple historical sources, it could not be extinguished with water. In fact, some accounts suggest that water made it burn more intensely. The only substances that reportedly had any effect were sand, urine, and a strong vinegar solution. It clung to wood. It clung to cloth. It clung to skin. The Arab fleet, experienced, disciplined, and prepared for conventional warfare, reportedly broke and scattered. The siege failed. Constantinople held. It would hold again in 717 AD, when another massive Arab force attempted the same assault. Greek fire was deployed again. The result was the same. Over following centuries, Byzantine chroniclers would document Greek fire repeatedly. Anna Komnene, a Byzantine princess and historian writing in the 12th century, described it as something that moved like a fiery whirlwind and could be directed at enemies with terrifying precision. Naval commanders feared it. Enemies tried desperately to replicate it. Enemy spies were reportedly sent specifically to discover its formula. None succeeded. Or if they did, the knowledge disappeared along with them. And here is the part of the story that makes historians pause. The Byzantine Empire fell in 1453 AD, when Ottoman forces finally breached the walls of Constantinople after prolonged siege. In the chaos that followed, the burning of libraries, the scattering of scholars, the loss of centuries of accumulated documents, the formula for Greek fire was never recorded in any surviving text with enough detail to reconstruct it. The empire that had guarded it for nearly 800 years was gone, and the secret went with it. So, what exactly is a mystery here? After all, fire has existed since the beginning of human history. Armies have used incendiary weapons for thousands of years. The Romans used fire. The Chinese developed early versions of gunpowder. Surely modern chemistry can simply reverse engineer whatever Greek fire was? This is exactly what makes the mystery so persistent. Because it isn't just that we've lost a recipe. It's that the behavior described in historical sources doesn't match any single substance or combination of substances that scientists have been able to definitively identify. Let's look at what the historical record tells us. Carefully. First, Greek fire burned on water. This is the detail that appears most consistently across independent sources. Byzantine, Arab, and Crusader accounts all mention it. Ships that were struck and then abandoned did not simply drift away. They continued burning even as they sat on the surface of the sea. Second, it was a liquid, or at least liquid enough to be projected from a device. Byzantine siphonarioi, specialized soldiers trained specifically in its use, operated pump-like mechanisms to spray it. Some accounts also describe ceramic containers, like grenades, filled with a substance and thrown by hand or launched by catapult. Third, it reportedly reignited when water was applied. This is the detail that modern chemists find most intriguing and most difficult to explain. Fourth, the smell. Multiple historical accounts mention a distinctive, terrible smell. This is not a dramatic embellishment. It's a consistent detail across sources that didn't necessarily influence each other, which gives it credibility. Fifth, its production was centralized and state-controlled. The Byzantine government did not allow Greek fire to be produced independently. Its ingredients were imported under strict imperial supervision. The people who made it were a small group of specialists, and they were, by most historical accounts, sworn to secrecy under penalty of death. Now here is where the mystery deepens. The combination of these properties, burns on water, projected as a liquid, possibly reignited by water, distinctive smell, state-controlled production, does not cleanly map onto any single known substance. Various individual properties can be found in known materials. Naphtha, a naturally occurring flammable liquid, burns readily and was certainly known in the ancient world. Quicklime reacts violently with water and generates significant heat. Bitumen, crude petroleum, has been used as a weapon across many ancient cultures. But no single substance, and no combination of substances yet proposed, perfectly explains all of the documented properties simultaneously. This is the core of the Greek fire mystery. It is not a mystery born of fantasy. It is a mystery born of specificity. The historical descriptions are too detailed, too consistent across too many independent sources, and too technically precise to be dismissed as exaggeration. Something real existed, something extraordinary, and we don't know what it was. Researchers and historians have proposed several serious, evidence-based theories about what Greek fire might have been. None of them are definitive. All of them have merit. The first and most widely discussed is what we might call the naphtha hypothesis. Naphtha is a light petroleum product, a naturally occurring flammable liquid that seeps from the ground in several regions of the Middle East and the Caucasus, areas that were within or adjacent to Byzantine trade networks. Naphtha burns intensely and readily. It spreads across water rather than sinking. It would have a strong, distinctive smell. It can be projected as a liquid. Proponents of this theory argue that Greek fire was an advanced refinement of naphtha, possibly heated, possibly combined with other materials like pine resin or sulfur to alter its burning properties, and delivered through a pressurized pumping system that the Byzantines developed specifically for this purpose. The delivery system, in this theory, may have been just as important as the substance itself. A heated, pressurized rejection of a refined petroleum product, directed through a bronze nozzle onto a wooden ship. That alone would be catastrophic. This theory is supported by the geography. The Byzantine Empire had access to petroleum seeps in the Caucasus region, particularly around what is now Azerbaijan and the Black Sea coastline. There is documented trade in these materials. It is also supported by the Arab account of the siege of 674 AD, some of which describe the fire as appearing to flow, consistent with a liquid petroleum product. The challenge with this theory is the water activation claim. Naphtha, while it floats and burns on water, does not reignite when water is applied to it. This remains unexplained by the pure naphtha hypothesis. The second serious theory involves quicklime, calcium oxide, as a key component in the formula. Quicklime is produced by heating limestone to very high temperatures. When water contacts quicklime, an intense exothermic reaction occurs. It generates heat rapidly, enough heat to ignite nearby flammable materials. This property directly addresses the most puzzling detail in the historical record, that Greek fire appeared to burn more intensely when water was applied. If Greek fire contained a significant component of quicklime, mixed with flammable liquid carrier, Then contact with seawater or with attempts to douse the fire with water could, theoretically, have triggered or accelerated combustion rather than suppressing it. This would explain what looked, to witnesses, like fire that fed on water. This theory has been taken seriously by historians, including John Halden of Princeton University, one of the leading academic researchers on Byzantine military history. In laboratory reconstructions, combinations involving naphtha, pine resin, and quicklime have produced substances that behave more consistently with the historical descriptions than naphtha alone. The challenge here is one of practicality. Storing and handling a substance that reacts to moisture would have been extraordinarily difficult, particularly on ships in a maritime environment. Keeping it stable during transport and then deploying it deliberately requires a level of engineering sophistication that the Byzantines may well have possessed, but that leaves little room for error. The fact that there are no recorded accounts of Greek fire accidentally destroying Byzantine ships suggests either that the storage problem was solved or that the quicklime component has been overstated. The third theory is perhaps the most thought-provoking, and in some ways, the most unsettling. It proposes that Greek fire was not based on a single exotic ingredient, but rather on a manufacturing process, a method of refinement, mixing, and preparation that was sophisticated enough that even if individual ingredients were identified, the final product could not be replicated without understanding the exact process. This theory draws parallels to other lost manufacturing techniques in history. The steel produced in medieval Damascus, known as Damascus steel or wood steel, had properties that modern metallurgists spent decades attempting to reproduce, not because the raw materials were unknown, but because the precise process of its creation had been lost. Roman concrete, similarly, sat under the Mediterranean Sea for 2,000 years before modern scientists finally identified the specific chemical reaction between volcanic ash, seawater, and lime that gave it its remarkable durability. The ingredients were known. The process was a secret. Under this theory, Greek fire may have used materials that were available and even identifiable: petroleum, resin, sulfur, quicklime, perhaps other organic compounds, but in proportions and prepared through a method so carefully controlled that no amount of knowing the ingredients would allow reconstruction without the exact steps. This would explain why enemy states, despite their best efforts and despite capturing Byzantine territory and personnel, never successfully reproduced it. They may have found some of the ingredients, but without the process, without the specific chain of steps that the Byzantine specialist engineers followed, it remained out of reach. And when those engineers were gone, the knowledge was simply gone with them. It is worth pausing here to note something that the Greek fire mystery reveals about knowledge itself. We tend to assume that important knowledge is always recorded, that if something mattered enough, if something was powerful enough, useful enough, significant enough, someone would have written it down. But history suggests otherwise. The most carefully guarded knowledge is often the least likely to be recorded, precisely because its value depends on secrecy. The Byzantine engineers who made Greek fire did not write instruction manuals. Their knowledge lived in their hands, in their practices, in oral transmission from master to apprentice. When the chain broke, when the empire fell, when the specialists scattered or died, there was no written record detailed enough to reconstruct what they knew. This is a pattern that appears across many civilizations. Roman concrete, Damascus steel, the acoustic properties of ancient Greek theaters, so precisely designed that a whisper on stage could be heard in the back row without amplification. These were not magical achievements. They were the result of accumulated practical knowledge, knowledge that existed in practice long before it existed in documentation. And sometimes, practice dies before documentation begins. Today, researchers are still working on the Greek fire question. New chemical analyses of archaeological residues from Byzantine harbor sites have offered small clues. Advances in the study of ancient petroleum sources have narrowed the geographic possibilities. Experimental archaeologists have built reconstructions of Byzantine siphon devices and tested various substance combinations. Progress is being made slowly, carefully, with a methodical patience that real historical inquiry requires. And yet the full picture remains incomplete. We know that something existed. We know that it worked. We know that it changed the course of at least 2 sieges that, had they succeeded, might have fundamentally altered the history of medieval Europe and the Middle East. We know that it was real enough to be feared by some of the most capable military forces of its age, and sophisticated enough that those forces, with all their resources and motivation, could not replicate it. But we do not know exactly what it was. And that absence, that gap, sits at the center of one of history's most genuinely fascinating puzzles. Because if an empire as powerful as Byzantium, lasting for over 1,000 years, could take a secret of this magnitude completely to its grave, what else have we lost? What other knowledge, practical, technical, profoundly useful, disappeared not in fire or flood, but simply in silence, in the slow dissolution